Now, next on our agenda, we have a presentation by Dr. Christine Angelini she's the director for the Center for Coastal Solutions, and she has a presentation on emerging research in the Charlotte Harbor estuary. Next slide. The purpose of this is to provide an overview of the mission and goals of the Center for Coastal Solutions, as well as an overview of their plans for working in and around Charlotte Harbor estuary in 2021. This relates directly to the water quality improvement and monitoring priority actions of the CCMP. So with that, I will go ahead and hand it over to Dr. Angelini.
Okay. All right, good morning, everybody. It's really a pleasure for me to have the opportunity to speak with all of you. And I really hope over the coming years that I get to know many of you that are in the audience, as my colleagues and I from the University of Florida are sort of expanding a lot of research and capabilities that we have at the university, and particularly through the center that I direct in your backyards in Charlotte Harbor in sort of the southwestern corner of the state of Florida. So let me give you a little bit of a background for our center. And as Devin mentioned, my goals today are to introduce you to the center, have an awareness so that you have some awareness of the capabilities that myself and my colleagues might be able to offer to you, but also to give you an idea of the type of work we're doing immediately that's kind of ongoing and going to sort of escalate over the coming years that may be of interest to you. And there are elements that hopefully we'll find opportunities to partner on as things unfold in the sort of the months and years to come. So let me give you a little bit of the context for our center. Please go ahead. So just to warm everybody up for the talk, this is not surprising to all of you, and many of you are on this sort of advisory committee, partly to work on these coastal hazards, whether they're water quality issues related to harmful algae blooms or pathogen outbreaks, but generally they're on the rise, both in your backyard in Charlotte Harbor, but also more generally across the state of Florida, as has been evidenced as very recently with the Piney Point spill that you see in the upper left-hand corner here, and a lot of these sort of unknown impacts of this spill to the ecology of the bay. So please go ahead. When I talk about coastal hazards in my presentation this morning, I'm going to be referring to largely the biological hazards that we're seeing in our coastal waterways. That are ultimately generated by physical and biological and chemical changes that we're seeing and they kind of interact to give rise to a variety of different types of hazards. And particularly in the state of Florida, what we're seeing sort of rising are both the incidence and composition and severity of harmful algae blooms, as well as pathogen outbreaks. So these are things like incidents where we have high numbers of fecal coliforms or other types of damaging bacteria in coastal waterways, as well as the incidence and severity of macroalgae blooms. And very sort of broadly, these biological events and other water quality hazards are both unpredictable. We don't really know when and where they're going to happen. We don't know how severe they're going to be. This is very true right now in Tampa Bay, for instance. We have no idea what the ecological implications of the Piney Point spill are going to be. But generally, they are increasing in frequency and severity, both because of climate change and how climate change is affecting sort of salinity and water temperatures and the acidity of our coastal waterways, as well as kind of precipitation changes, as well as changes in population growth. And if I heard the statistics correctly, I think the county that Cape Coral is in is perhaps one of the fastest growing counties in all of the state of Florida. So this is the population growth and the sort of impacts of that population growth on freshwater extraction, releases of nutrients into coastal waterways. These are kind of amplifying factors for these biological events. Go ahead. So the consequences of these water quality hazards, I think many of us know them fairly well, but they involve both damages to the environment, to public health, as well as environmental or economic degradation. Go ahead, please. So in some of the systems that I have been working with, we're seeing large-scale declines in the presence and sort of health of our oyster reefs. This is in this picture is a site that I work in Cedar Key, just maybe 100 miles north of where many of you are located in Southwest Florida. And this used to be a vibrant oyster reef, and now we just see a few piles of living shells along its margins. But what we're seeing sort of in our oyster reefs is symptomatic of what we're generally seeing in our coral reefs, the health of our seagrass meadows, marshes, and mangroves. And they're varying in their relative sensitivity to sort of changes in water quality. But in general, none of them seem to be kind of nearly as healthy and vibrant as they used to be. And we're all kind of on pins and needles to know what the kind of fate of these systems are going to be as these biological hazards and climate change continue to amplify. Go ahead, please. We're also seeing changes in the health and quality of life of our coastal residents. News flashes like this are not uncommon, particularly in your neck of the woods. And, when we're not able to go out and walk our dogs and spend time with our family on our beaches or go out and fish, because the quality of the waterways and the health of what we're fishing out of these waters is not suitable. It really has a direct impact on the quality of life that we have in living in this state and near the ocean and trying to derive benefits from that proximity. And so I think this is something that many of us have had to change our plans and make different decisions because of the health of our waterways. And I think this is a very real and tangible impact of them. Please go ahead. In addition, we're seeing sort of effects on our economy. Some of the papers about red tide in particular and their impacts on Southwest Florida are just coming out. But just to summarize some of the work by Krista Court and her colleagues, they're seeing losses in Airbnb and other types of peer-to-peer types of residential accommodations, tourism revenue losses, recreational fishing losses associated with red tide bloom. So particularly your part of the state is very much feeling the impacts of these water quality hazards in the pocketbooks of both state and local government, as well as in critical businesses and individuals trying to make a livelihood and make a living in this area. Please go ahead. So what is being done right now, and many of you participate in this, is that I think there has been a huge effort, and this is an escalating effort over the last 10 to 20 years to really monitor what's happening in our coastal waterways. So this is coming from both efforts at the federal government level with NOAA and others that are kind of continually watching our coastal waters through programs such as Coast Watch that analyzes data coming from satellites, but also just tremendous amount of on-the-ground effort coming from the aquatic preserves, FDEP, the EPA, and smaller organizations like SCCF and others in your sort of local waters that are really trying to kind of get a pulse on what's happening everywhere all the time in our coastal waters. And so I would say there's been just a huge escalation in sort of the temporal and spatial regularity with which we're collecting information about the environment. Go ahead, please. But there's also a tremendous amount of effort that's going into consolidating that data and putting it in really useful databases. And that's also coming from larger organizations supported by the federal government like GCUS and Socorro. The sophistication of their data portals has really taken off in the last number of years. There's data visualization systems, for instance, embedded in these tools. In your backyard, the water atlas that's maintained by the CHNEP is one example of how data is getting kind of collected and aggregated. And so I would say, we also have a lot of kind of big database tools now at our fingertips. Go ahead, please. However, I would say we're still at a loss about what the root causes of many of these hazards are on our coastal waterways, as well as what types of solutions we should be pursuing. And I think there's three main reasons why this is. So go ahead, please. The first is that our coastal waterways are incredibly complex. They're occurring at the interface of all they occur at the base of watersheds. They're at the interface of the ocean. And so both what's happening upstream in terms of land use and water use change, as well as all the changes that are happening in the ocean due to climate change kind of collide at the coast. and there's lots of people there, and it's really difficult to kind of pinpoint what nutrient sources, for instance, whether it's changes in river flow or ocean forces, really give rise to events like red tide in your backyard. And I think this kind of broad scale interconnectivity between the watershed and the ocean, it really is affecting what conditions arise in the coastal zone, but it's really difficult to kind of resolve the relative importance of different factors just because of the sheer complexity. All right, second, please. And to date, our ability to kind of work through this complexity, I would say it's really been limited so far because the type of information and the type of modeling we do on what's happening in the watershed, what's happening in the coast, and what's happening in the ocean has largely been decoupled. So we have different people that are working upstream in the freshwater areas. We have another camp of people working in the coast and another group working in the ocean. And we really haven't been able to integrate across those different scales to really kind of look at all that interconnectivity across space and time. All right, go ahead. And then the third thing is that I think we've really struggled so far, and this is kind of because of where we are in technological advances and really harnessing the power of data that we're getting from different sources. So as an example of this is all over Charlotte Harbor, there's regular in the water data collection being sort of gathered on different types of water quality parameters, but we haven't really been able to fuse that with the type of information that we can get from remote sensing and satellite. And those two types of data sources have very different spatial and temporal and targeting resolution. And so basically, we haven't been able to kind of stitch them together to get a really sort of as profound sort of view of what's happening in our coastal waterways as we'd really like to have. And so we can't really see through the complexity yet because we haven't been able to harness the power of information coming from different types of sensing platforms. All right, go ahead, please. So I guess the question that we have, kind of facing us is, we're kind of muddled in this complexity right now is, can we turn the tide and build a more proactive coastal hazard response paradigm? Can we kind of get on top of this kind of uncertainty and complexity? Go ahead. And I think that the answer is yes, absolutely. I think both the stakeholders are from working in different spaces and in different sectors are really ready to start trying to work through this complexity and blend together the work that they're doing with that of others. But I also think that the databases and the data sources are getting to a level of sophistication now in terms of their spatial and temporal coverage and how kind of clean they are, that we can actually start, we're really kind of ready to do the next level analyses. And I think secondarily is that some of the transformation technologies in terms of artificial intelligence, in terms of how we manage large data sets, how we fuse data from different types of sensors is really kind of coming together. Go ahead, please. And so it's really kind of emerging out of this broader context that I'm founding this Center for Coastal Solutions, and that I think the University of Florida sees a real opportunity to apply some of the capabilities that we have on campus in terms of our expertise and some of our physical infrastructure to really sort of fill this gap and really sort of take the lead in trying to work with partners to build these next generation capabilities. Go ahead, please. So our mission of the center is to be providing the state of Florida and many of you who are working in kind of decision making about how to address these water quality hazards, real-time intelligence critical to preventing and mitigating water quality hazards, and particularly those biological hazards that I talked about earlier in my slides. Please go ahead. So what does real-time intelligence look like? What do I mean by that? So what I'm going to walk you through in the next few slides is what we see as the 5 to 10 year vision of what we would really like to build at the center, but in coordination with many other partners. And I'll talk a little bit about our partnerships later on. But what we're envisioning is building what we're calling a comprehensive coastal observing network, or CompCon, that generates 3 key products that are really vital, we feel could be really vital for supporting proactive decision making. So the first is real-time high-resolution 3D maps of coastal waters. The second is accurate and local scale water quality forecasts, so we know what's happening in the days to come. And finally is a coastal response simulator, and I'm going to talk to you about that and give more details in the coming slides. Go ahead, please. But these are the three prongs of what we're hoping to generate. So the first product that we're really looking to kind of develop is real-time, high-resolution visualizations, almost digital twins, if you will, of what's happening in our coastal waterways. So how these maps will be generated is by fusing the data coming from different types of sensors. As I mentioned before, we really want to be harnessing what we're getting from increasingly sophisticated satellites, as well as increasingly sophisticated in the water sensing platforms, to create 3D visualizations of different hazards that are in our coastal waterways. So imagine you could open in sort of a browser and you can actually zoom in to Charlotte Harbor and see the distribution of hypoxia patches or low oxygen waters. You can see, where red tide is and its relative severity based on how kind of bright that different feature are. But this is really what we're envisioning, is being able to create these near real-time and high-resolution mapping capabilities. Please go ahead. Just a bit more information about our water quality forecasts and the capabilities that we're trying to build out in this space. What we know is that there's different types of forecasts that are already out there that are telling you what may happen with regards to red tide events. So these are some examples of the forecast that exists from NOAA's HAB forecasting system, and then from the group from USF, who's really kind of led the charge in creating more kind of regional scale maps. But what we would really like to do is add some sophistication to these existing programs by providing information at the individual beach and individual waterway scale, and in particular related to changes in nutrient concentrations, salinity, dissolved oxygen, and then how those are related to sort of the incidence of phytoplankton blooms as well as macroalgae blooms. So really sort of forecasting not only changes in sort of gross scale kind of behavior of, say, red tide, but the intricacies of changing nutrient dynamics and their effects on ultimately affecting things like macroalgae blooms and phytoplankton. Please go ahead. And then our final kind of component of what we're envisioning building in terms of a suite of decision-making tools is a coastal response simulator. And this is really meant to be kind of an ecosystem where those of you who are tasked with making decisions about how to address different water quality hazards can probe what the scale, the location, the timing, and the sequence of different management interventions may be, and really try to optimize those different types of interventions, both for cost savings, but also for generating measurable and real impacts on improvements in water quality. So just to walk you through what this might look like, and this is really kind of our longer term vision and goal of where we want to be building to. We see the mapping and the forecasting as things that we can work on in the next 5 years that really sets us up to build this coastal response simulation system. But you can imagine that, those of you who are all tasked with addressing, say, red tide or a macroalgae bloom event, get together and you're able to put together, please go ahead, Nicole, a set of different types of interventions that you might explore. And this could range from nutrient load reductions from certain neighborhoods or parts of your local community. It may involve converting septic tanks to more sophisticated kind of water treatment systems, modifying river discharges and providing recommendations to, say, the Army Corps about discharges of Lake Okeechobee. And finally, it might also involve different types of interventions like expanding the scale of oyster reef restoration to harness the kind of natural filtration capacity of filter feeders like oysters to improve water quality. So you can imagine, go ahead, coming up with a list of these different types of interventions and actions. And what we can do is input those different types of actions into a reinforcement learning type of an ecosystem where we can actually optimize in space and time with sort of regulatory constraints, real regulatory constraints, the potential sort of sequence and timing of those different interventions. And what we can get is sort of optimization surfaces that tell us this stream of actions in this location in this sequence of timing can really generate improvements, real improvements in, say, downstream benefits to reductions in nitrogen concentrations or reduced incidence of events like harmful algae blooms. Go ahead. So from this comes, you get these kind of optimized interventions, and these are sort of fed back through a decision-making system to identify, what is financially feasible and sort of do we have the willpower or political will to sort of execute at any given place and time. So this is kind of really where we want to be building. And of course, this, please go ahead. This tool, as well as, one more, Nicole, sorry. As others, has to come from really strong and sustained, coordinated sort of partnerships with both other academic institutions that are leading research in this area, and in particular in your area, FGCU and the University of South Florida, as well as other research institutions like Moat. These are all what's pictured here are different partners that we are already in communication with. They've kind of developed the sort of our vision for these products. And we know that we either need them critically for their technical capabilities, for their supplying of data to our system, or for their ability to help us basically engage decision makers and other stakeholders to make sure that these tools are being designed and adapted in such a way that they're actually useful and actually used. So the last thing that we want is to be developing things that ultimately have no user group because they're not designed in a way that is actually useful. So I guess this talk here is really my first invitation to tell you that we see you as a part of that user group and are really looking forward to your engagement and helping us make sure that the way that we build the technology for these tools over the coming years actually relates to what you need delivered to you to support decision making. Please go ahead. So we're actually starting building this CompCon system here in Charlotte Harbor, starting kind of January 1. We have support from a private donor to get this work started, but we've been applying for proposals to a variety of different federal and state agencies to solicit additional support. There's other projects such as that led by Eric Milbrandt and his colleagues at North Carolina State and UF through the EPA. So we're kind of harnessing existing funded projects to kind of get this CompCon system going. But we're working in your backyard because this is an area that has not only great capabilities in terms of widespread water quality monitoring supported by the aquatic preserves and sort of aggregated by the CHNEP, but also the real-time water quality data collection system that's stood up by the SCCF, and that's what the sort of the stations where they're collecting data are shown in blue here. This is also, I think, ground zero in the state for water quality hazards, ranging from blue-green algae to red tide to macroalgae blooms, hypoxia event. You're extremely vulnerable to climate change, both because of upstream changes in precipitation and sea level rise. So if we can get this system to work here, we feel like there's a great capability of expanding it geographically across the state. And so what we're really focusing on in the coming years is building the backbone of this 3D mapping system, as well as our forecasts. And as I said, over time, it's really going to take a lot of sustained coordination to build the simulation system. Please go ahead. So I'll give you a brief overview of some of the things that we have going on already related to this project. So we're starting to build sort of fuse data from satellites and in the water data collection systems. This work is being led by my colleague Paul Gator and his graduate students Alan Wang and Ron Frick. But we also have collaborations from the National Geospatial Agency and the SCCF. We're using their data as kind of ground truthing data, but we're building basically what we're calling a plume tracker to track the discharges from the major rivers coming into Charlotte Harbor, because we really feel like the river discharges are a critical kind of part of the biological reactor, if you will, that's in Charlotte Harbor. And so if we can understand what's coming from the rivers and the sort of upstream urbanized and agricultural areas, that's really important sort of forcing factor to what ends up happening in Pine Island Sound and other parts of the harbor, as well as in the nearshore area. So we're really working on kind of resolving what's happening with the river plumes themselves with this first generation product. We're also identifying when and where the hazards are kind of forming and arising by applying some of our capabilities in doing nonlinear time series analyses. So this is kind of looking at all the noise and kind of changing nitrogen and phosphorus and salinity levels and looking at kind of ultimately their relationships to the incidence and severity of different types of water quality hazards like hypoxia events and red tide blooms. So we're doing this in partnership with the CHNEP. The city of Cape Coral has been involved in this work, and Maya Roberts in particular is kind of helping us shape some of the kind of first generation products that we'll be working on in this area. And I've hired a postdoc, Miles Medina, that's really has excellent capabilities in this area. But generally, what we're really striving to do is identify, the relative importance of changing nutrient loads and water chemistry and driving the presence and persistence of different types of harmful algae bloom events in this region. Go ahead, please. We're also working on building, and you can, actually, this isn't the video here. We're also building out a high resolution coastal forecasting system. If you have questions about how this is different from the SCCF models, I'm more than happy to go into that, but I'm not going to talk about it in depth right now, but I'll tell you there's different capabilities and functions in our model relative to that, which you see coming from the University of South Florida system. But what we're really striving to do is deliver these local beach scale predictions of the incidence of red tide, macroalgae bloom events, et cetera. But to do that, we have to build basically a well-functioning forecasting model. And over time, the system that we're currently using to predict changes in salinity and dissolved oxygen and water temperature is going to gradually be integrating sort of nutrients and other drivers as well. So just know that we're building the backbone right now, but we're hoping to add sophistication to this in the coming years. And this is being led by my colleague, Maitani Olabarrieta, and her postdoc, Lu Ming Shi. All right, go ahead. Just to give you an example of what this looks like, this is a simulation in the early months of 2021 of what this modeling system will be producing. So this is a simulation of basically water density. We have also simulations of water salinity as well, but what you can see is kind of some interesting features looking at sort of the shedding of some of the water coming from interior in the estuary and sort of shedding offshore. This may be really important at looking at these dynamics, at looking at when and where sort of river discharges may be interacting with, say, offshore red tide blooms. So when does the river water actually get into that nearshore region offshore and potentially feed those blooms? As well as looking at other critical features like what are the residence times that we may see in areas like Matlacha Pass, where we have some chronic water quality issues in this region. Go ahead. With this modeling framework, we can also look at interesting things like cross sections and looking at basically different levels of mixing that we see between the Caloosahatchee River and the bay itself. So that what you see on the left-hand side is a simulation of changing water density across this transect from sort of upstream to downstream. So what you can see is the kind of the pulsing of the river along with sort of the different tidal events, the kind of high spring and neap tides and high and low tide periods. And being able to do these types of cross sections and visualize the model outputs in this way may be really important for us to look at things like stratification. That's really important for driving hypoxia events, for instance, so we can start probing under what conditions are we getting stratification happening in the bay, and under what conditions would we get, say, river water that may be high in nutrients trapped in different locations, and what are the kind of forcing factors behind that. So this is kind of at step one. This is where we are in developing the model right now, but we have a number of proposals to continue building this capability in your backyard. Go ahead. And the third thing I wanted to mention is that we're really taking a close look at policy and regulatory constraints to different types of management interventions that we may want to pursue as a sort of as a larger community. And so we have an expert in sort of coastal policy and environmental policy here at UF that's taking the lead on this, and we're really looking forward to working with others in this community on this in this space. Tom Ankerson is sort of taking charge of our science to policy efforts. He's done a variety of work working on different types of kind of issues of interest to local stakeholders across the state, ranging from things like coastal armoring to recreational rights to sandy beaches to boating issues in the state. And so Tom is a real wealth of information. And the two ways we're really going to kind of scale up our policy work is that we have a coastal policy analyst that's going to be at a sort of a JD or a PhD level. We're interviewing candidates next week for this position. This person will start in June 2021, but they're going to be working with some of you and with Tom to make some policy recommendations related to improving water quality in this region. And as well as working in coordination with Florida Sea Grant, which is co-sponsoring this coastal policy analyst. And we also have a coastal policy lab, which is teams of graduate students from the law school, engineering, and science disciplines that are going to be coming down to your local area in the fall. And we're going to be working with local stakeholders on student-led projects in both the fall and the spring of this coming academic year to work on different types of topics and, again, write white papers and other types of documents to support policy recommendations in this area. So if you have interest in getting involved in helping sort of mentor student groups, I would be really, or have topics that may be of interest, I eagerly welcome you to reach out. So please go ahead. So the University of Florida, I think, is a really great place to do this. I'm going to go ahead, Nicole. I'm just going to briefly mention a few of the reasons why we feel like we're particularly well suited to do the work that I just described. The first is that our institution is extremely motivated to better support the coastal margins of our state. They see the center as something that is trying to harness the comprehensive capabilities of UF to support our coastal communities. It's in line with our sort of the mission of our university as a land grant institution. And so sort of putting their money where their mouth is, UF has already invested over $1 million to support the center in getting started. But they've also given us 4 new hires. And so we're in the process, and we might actually get 5 as a result of this hiring process, that are working and basically using artificial intelligence, using some of this sophisticated sort of data fusion technology. And so we have additional faculty dedicated to our program that may be working with you as soon as this coming summer. Go ahead, please. We also have, and you can just click forward the next 3, Nicole, just for, yeah, that's great. Perfect. We also have an amazing supercomputer that was just donated to the university. So we have the kind of computational sort of horsepower to do this kind of big data analytic work and sort of K to grade training to support broader education. The faculty and students I'm working with from across campus are just awesome. Like, we have some extremely talented, internationally known leaders in the areas of work that I just talked about. We're really striving to do an excellent job on public-private partnerships as well, and make sure that this is not a University of Florida show, but it's a collaborative kind of effort. We can't build these tools in isolation. We know that, and they're not going to be used if that's done. So we're really striving to make sure the way that we do partnerships are meaningful and reciprocal and well supported. And then, of course, as an academic institution that has kind of nodes all over the state, we're really dedicated to making sure that the knowledge doesn't stay at UF, but does broadly disseminate across the state, and that happening through both, our students that are trained, but also our extension capabilities. Go ahead. Thanks. So we're moving from this I really see that we're on this trajectory as a broader community of moving from this very reactionary place that's costly and damaging to our environment to more of a predictive and finally a proactive space. And I really am encouraged that I think I'll see this in my own career and lifetime, and that many of you are able to see this as well. And hopefully the center helps it be a vehicle for this kind of transformation to happen. Go ahead, please. So just in closing, I just want to leave kind of contact information. Please feel free to email me if you're interested or have ideas or feedback. We also have a monthly newsletter if you generally want to kind of passively learn about what we're doing, and you can sign up for that on our website, which you can easily find using the link at the top. So thank you so much for your time and attention. And I appreciate you. I was a little jerky today because I'm used to being the master of my own slides, but thank you, Nicole, for bearing with me. So thanks so much. And yeah, happy to take questions now or whenever it's suitable.
Thank you, Dr. Angelini. That was really interesting and a lot of great information. I'm excited to see where this goes in the future. I totally agree that we definitely need to be integrating the data and the modeling capacity and all the work that's being done both inland and on the coastal front. So really exciting work. And with that, if anybody has any questions, feel free to unmute, announce yourself, and provide your comment or question.
This is Dave Seeley. I have a question. Excellent presentation, first of all, and I congratulate you on your efforts and wish you the best in any way that I can help. I look forward to working with you. I'm currently involved in a multi-million-dollar restoration project in the Caloosahatchee River funded by the state of Florida. And at the same time that we're having this meeting, the South Florida Water Management District is having a water quality meeting for the C43 reservoir. And my question is, I'm wondering, one of the logos I noticed that was missing from your slides was the South Florida Water Management District. And I wonder if you could just give me an idea of how they might be involved in this process.
Sure. So it's basically connections that we still need to make, and we are sort of indirectly using some of their data and information that they sort of gets integrated into the water atlas. So the data streams that they're collecting are there, but I don't actually have the personal connections yet at the water management districts. So you're absolutely right. I think that's kind of a critical next step that we have. We have some connections with the Army Corps, kind of working on, way upstream at the sort of at Lake O. But if you have any suggestions of who we really need to kind of connect with, I'll just tell you a lot of our work kind of at the watershed scale is going to be led by a colleague, David Kaplan, and his student is just starting May 1. So we're literally just kind of cracking open that upstream sourcing and thinking about those dynamics now and as they relate to kind of what comes into the river, into the coastal area. So please recommend anybody that I should absolutely be connected with at the water management districts. I would encourage that. Thanks.
Okay, yes, thank you. They're spending about $1 billion on that reservoir, and there is currently no stormwater treatment or STA component to it. And a lot of us have been pushing very hard for that. And it seems like your modeling your predictive modeling especially would indicate the importance of that. Thank you.
Yeah, and I think that one of the things, so just to give you a quick preview of one of the things we're working on and waiting to hear back from the Army Corps if they'll support this, is to better understand basically under what ocean conditions should the river discharges be sort of released to allow for more rapid flushing. Because ultimately the kind of the near shore and the coast pushes on the toe of the rivers, right? And either traps things or allows kind of leakage of that material and ultimately dilution. And so one of the really critical things we think we can offer is understanding that sort of oceanside forcing and how that relates to basically ultimately how long, the river water gets trapped in the near shore and in the bay itself or in the harbor itself. So we're hoping that gets supported. And I think you're right. The coordination we need to have with them is the time is now for us to start having those conversations. Yeah.
Very good. Thank you.
Thanks.
This is Jennifer. I would just mention that we do have TAC members from both the South and Southwest Florida districts. So we'll send you their contact information and you can follow up.
Thank you, Jennifer. That's great.
I see Stephen Swa has his hand raised. Do you have a question?
Yeah, a great presentation. I had just a question about the climate change elements being looked at. You mentioned rainfall patterns and sea level rise. I've seen some things lately, some research, I think, talking with a little bit with Mo Marina's starting to look at this. What about increases in CO2 and acidification? Do you think that the ability for algae to photosynthesize greater in a nutrient-rich environment as well, those two things combined could be a factor in the future in increased algae growth?
Yes, I think both the changing water temperature
Yeah.
as well as basically the distribution of salinity in the system because of rising sea levels, as well as, of course, like the acidification component. So I didn't heavily talk about the sea level rise component or excuse me, the climate change component of this work. And part of that is because we feel like we have to build the backbone of like the technology components, and then we can start basically forecasting over longer periods of time. So the forecasts I've been talking about are kind of over the course of 5 to 10 days. And once if we can do that well, then we have to build out basically the longer types of systems. But we can't take our eye off the ball on those longer term kind of climate change components. But yeah,
Well, even in the short term, like right now, if CO2 is increased, can that be contributing in combination with the additional nutrients to cause algae blooms to be longer and more severe? And
yes, I think it's definitely possible. And I do think that, there's a lot of additional work that we need to be doing for different types of algae species on looking at how opportunistic they are related to changing, acidity and temperature and salinity regime. So it's difficult to disentangle the relative importance of the different drivers, right? And so, even over the short term. But I'll tell you, I think you're right that we're in the middle of climate change right now. It's in our rear view mirror as well as very much in our sort of foreground. And so we have the opportunity to even leverage trends in recent history and patterns in recent history to look at what the impacts of climate change already are on these systems. So I think that's a really, really sound and important point. I'm probably not the most competent to comment on basically, in particular, the acidification changes, but will bring that up with some of our colleagues like Ed Flips and others that are doing some of the phytoplankton work to have a better answer next time.
okay, well, I
related to
appreciate that.
But
And just to be real clear, when you talk to them, the question is not so much about sea level rise, but it's about the fact that these algae use CO2 to photosynthesize.
Yeah.
And grow, essentially. And therefore, if we have increased CO2 combined with the nutrients, are we likely to see some pretty significant changes, which I think we're starting to see, which is kind of the concern.
Yeah, I think it's it's a regime shift that generally we feel like we're seeing away from the dominant primary producers of seagrass in this system to more of the macroalgae and phytoplankton, right? That are kind of winning this battle. And so the cost to sort of the systems we ideally want to have there as a result of these changes is, and where we are on kind of the potential regime shifts between those systems is, it feels like unnerving, like knowing whether we're close to a threshold there. It's encouraging that it seems like the seagrass cover, I could be wrong about this, has been generally fairly stable in Charlotte Harbor over recent years anyways, but that's definitely not true of the Indian River Lagoon and definitely a big concern right now in Tampa Bay. So I wouldn't be surprised if there's, we see instabilities in the system, in the ecological systems as we move forward.
Thank you.
Yeah, thanks. All right.
Right. Unfortunately, we're sort of out of time with additional questions, but I will say that Christine has put her email address in the chat box. So if you do have additional questions, feel free to reach out to her directly, and I'm sure she can point you in the right direction and you can get those questions answered. Thanks again, Dr. Angelini. Really great presentation, and again, excited to see how this project moves forward.